In this video, we're going to be looking at how to find the angles in right triangles when I know two side lengths. I'm going to keep this SOHCAHTOA written out to help me remember which angles and ratios go together. First, I'm going to look at this triangle on the left. When I compare where these sides are in relation to theta, I see that 4 is my opposite side and 5 is the hypotenuse because it is opposite of the 90-degree angle. So I'm going to go over here and I see that that is my opposite and hypotenuse, so that's going to be my sine ratio. So I'm going to write out the sine of theta is equal to 4/5. Now, in order to get theta by itself, I need to undo that sine function. So I need to do inverse sine to both sides, leaving me with theta equal to the inverse sine of 4/5. And then when I entered that into my calculator using the inverse sine, I noticed that my angle theta is 53.130 degrees. The second triangle that I'm going to look at, I noticed that the 6 is next to theta. The 6 would be the adjacent side, and the 13 is the hypotenuse. So if I go back up to my SOHCAHTOA, I see that I have the adjacent side and the hypotenuse, so I'm going to use the cosine here. So my ratio would be the cosine of theta is equal to the adjacent side over the hypotenuse. Now, in order to get theta by itself, I need to use inverse cosine on both sides. That cancels, leaving theta equal to the inverse cosine of 6/13. And then when I enter that into my calculator, I make sure that I do second cosine to get the inverse key, and that gives me an answer of 62.514 degrees. The last problem that I'm going to look at is this one right here. Again, I'm going to compare where these angles are in relation to theta. So this 10 is the opposite side, and 5 is the adjacent side. So I'm going to go ahead and label them opposite and adjacent. And then I'm going to come back over to my SOHCAHTOA and I'm going to look, I have opposite and adjacent. That's going to be my tangent ratio. So I'm going to come over here and I'm going to write the tangent of theta equals the opposite side over the adjacent side. Now again, to get theta by itself, I need to do the inverse of that tangent ratio. So I get theta is equal to the inverse tangent of 10/5, which I know is 2. So into my calculator, I'm just going to put the inverse tangent of 2. And depending on the calculator that you're using, you might get two different answers here. We want the decimal form of this angle. I'm using this GraphenCalc app, and when I put in the inverse tangent of 2, it gave me this fraction approximation. Well, I really just want the decimal. I don't want that as a fraction. So what I'm going to do to correct that is do the inverse tangent and then just put that decimal point after the 2, and that's going to tell my calculator to give me a decimal. If you're using a regular like TI-84, this won't happen, so you can just go ahead and put inverse tangent of 2. Anyways, that should give me my degrees, 63.435 degrees. So hopefully that helps you decide which ratio to use when you're trying to find the angles, and then how also to set up your equations and show your work so that you can better understand which ratio we're picking and why, and then how to use the inverse. Thanks for watching.